So good morning, everyone. A warm welcome to day 5, the final session of our Imagery and Remote Sensing webinar series. My name is Samkit Bagmar, your host for this webinar series. I contribute to the Imagery and Drone Solutions business here at Esri India. So it's wonderful to see you all here again. We have again a dedicated turnout for our final day as well. So before we get started, our standard housekeeping reminders. First, if you have any questions during the presentation, please feel free to drop them in the Q&A box in the chat box here at any point of time. We'll address as many as possible live through chat, or probably we'll take it towards the end of the session today. Secondly, for those asking about recordings, yes, full session recordings of the entire 5-day series will be shared with you all on your registered email IDs. Also, we'll be loading it on our webinars page, Esri India's webinars page for you in the coming days. So Dhanraj has already shared the same link with you in the chat box, right? So it is not uploaded immediately right now. It will be uploaded in a couple of days from now. To connect the dots across the entire week, what all we did, let's take one small moment to look at how we have come, right? So day 1, Monday, we started with Geo AI and deep learning, right? For automated object detection, land cover mapping, and so many other things. Right? We covered that on Monday, and on day 2, we scaled from desktop analysis with Image Analyst for ArcGIS Pro to Image Server for ArcGIS Enterprise. How you can use both of them together for advanced image analytics, data cataloging, so many other things. On day 3, we covered reality mapping with drone to map, site scan, reality for pro, and reality studio to generate photorealistic 3D foundation models for digital twins. Yesterday, that is day 4, we unlocked advanced spectral analytics and no-code deep learning workflows with ENVI software. Today, on day 5, we wrap up the series with a technology that operates completely independent of daylight and weather conditions, right? So the title for today is From Microwave Pulses to Insights, Redeeming Pulses into Information. So optical sensors are powerful, but they are limited by cloud cover, atmospheric haze, and darkness. Synthetic Aperture Radar, that is SAR, solves this by sending active microwave pulses down to Earth, delivering reliable day or night all-weather imaging. So in today's session, we'll explore ENVI SARscape, the industry-leading software technology that transforms raw radar reflections and microwave pulses into meaningful geospatial intelligence. So today we'll be looking at how radar pulses penetrate through clouds and rain to observe land cover, surface water changes anytime, anywhere. Right. We'll also see how SAR interferometry tracks land subsidence, structural displacements, landslides, seismic activity with extreme precision. We'll also see how complex SAR datasets are converted into easy to understand maps and time series reports that integrate straight into the ArcGIS enterprise ecosystem. Now we'll also explore how to work with NISAR data, right? So everyone is talking about NISAR, which is a joint collaboration between NASA and ISRO, and we have launched SAR imaging satellite, right? So we have some data sets already that have come out, and we will be exploring those data sets as well. So today you will see how radar data moves from complex microwave signals into vital decision-ready insights for disaster management, geotechnical monitoring, infrastructure planning, and so on. So to guide us through all these topics that I mentioned in this final masterclass, I'm delighted to introduce a speaker to you, Abhishek Kumar again. Right? So Abhishek is from our Imagery pre-sales team. And we also have Manjusha Singh, the head of Imagery pre-sales, who will be supporting Abhishek today. Abhishek brings deep domain expertise in SAR processing as well, along with the other imagery sessions that you earlier attended. He also works on radar interferometry and spatial analysis and will walk you through advanced workflows step by step. So without any further delay, let's get started. So Abhishek, over to you.
Thank you, Samkit. I welcome you all to the last but yet another insightful session of this masterclass, which is about SAR image processing from microwave pulses to the insights. We'll walk to the agenda and what we will be seeing in this masterclass for next 45 minutes. So to start with, I will lay on some insights on why we should use SAR and give you a overview of SARscape. Within SARscape, how time series analysis is done and what are the solution-ready tools that are available in SARscape for analytics. After those, we will see how displacement, deformation analysis, and mapping is done using SARscape and its interferometric tool. Again, since this is Esri ArcGIS ecosystem, I will lead you towards how you can visualize the output and product of SARscape into the ArcGIS enterprise environment. So to start with, in today's world, when we have lots of sensors on board with optical sensors and microwave sensors, why should we go towards synthetic aperture radar or SAR? So the basic why we should choose active sensors are that it gives you 24/7 coverage, be it day or night, and it reduces the cloud within your image. So when you have SAR image at your play, you can work on applications such as maritime activity monitoring, as well as agriculture and different domains where you can see the surface of Earth throughout the day and night 24/7 without having the interference of cloud. So this is why SAR comes with this much advantages. One another advantage of SAR is its resolution. So having range and azimuth resolution, you get clearer and better pixels for the insightful analysis where you can identify different kinds of feature over the surface of Earth and you can monitor the land surface for different activities such as displacement and deformation with precision and very much accuracy. There are some geographic distortions and geographic conditions which comes within SAR. So we should be mindful of those geographic distortions when working with SAR. So there are tools available to reduce these kinds of distortions within SARscape, but we should, as an analyst, know why these distortions come and what are these distortions. So when when a SAR sensor captures the surface of Earth, it sends microwave pulses towards the surface. When those pulses records the bottom first and not the top, there is a distortion called foresightening, where the feature appears shorter. This is called foresightening distortion. Another distortion is layover distortion. So similar thing happened, but in the case of bottom here, the top gets captured first. Suppose there is one 120-story building and the top gets captured. So the first thing to capture is the top. So the feature will appear very steep and laid over to other feature. So this is yet another kind of distortion. And shadowing is that there were too many features shadowing other features behind them. So those pixels appear darker in the area. So these kinds of distortion comes when we work with SAR images. To remove these distortions, there are many tools and filters available within SARscape. So let's know what are the capability we get when we use ENVI SARscape. To start with, you get automated tools that quickly ingest and prepare your data for analysis. There are tools which can ingest data directly from the raw product and give you the analysis in very few pushes. Both kind of data, which is phase data and amplitude data that comes within a SAR image, can be analyzed and can be harnessed for your purpose within the tools of SARscape. When you work with SAR data, it is very much evident that you would require large amount of data set, multiple data set. So you can work within cloud environment and you can scale up your analysis and you can change your computing environment based on the scale of activity. there are application supports and different kinds of polarization supports available within the SARscape, where you can do multi-image analysis using different tools to harness the phase information, pole information from the SAR images. So what are the different tools which are there which provides you these capabilities? So ENVI SARscape comes with basic processing where you can do pre-processing of your SAR data. Since we know that SAR as a raw data comes with many kinds of anomalies within it. To process it, we need to have different kinds of tool like multi-looking tool, co-registration tool, speckle filtering tool, all those things. So these tools come within SAR basic and module. Along with basic module, you get focusing and gamma Gaussian filtering, where there are lots of filters available to process your images and make it better for visualization and analysis. For interferometric module, we get interferometric tool, scan-SAR interferometry, SAR polarimetry, and interferometric stacking modules. These are ancillary modules within the core module. They support the displacement and deformation mapping. They provide the tool which have capability to monitor the changes in the surface of Earth, and they can track minimum very precise level of surface movement for, let's say, landslide, for earthquake activity, all those tectonic activity as well. So here I will show you one visual example of the geometric effect which you saw on the in the previous slide, where you can see the red pixels are layover and the blue pixels are shadows. So when we proceed with the analysis, these kinds of distortions and these kinds of geometric effects uh, in return affect our analysis and diminish the visibility of the output. So in order to reduce those things, we have different filtering tools and different pre-processing tools so that we can get a crisp and clear analysis with very much accuracy. Since there are lots of payloads of SAR which have been launched for observation of the Earth, there are lots of sensor support capability available. This is the wide range of sensor support, where you can see the latest sensors such as Capella, ISI, NISAR, Synspective, etc. are available within the SARscape module which you get. This sensor capability allows you to do various processing and analysis and work on applications such as activity monitoring, ship detection, flooding, agriculture, coherence analysis, deformation mapping, subsidence mapping, etc. And there are lots of other applications as well based on your interest. Coming towards SARscape Basic provides you the makes you capable to process the intensity available within the SAR image. To having processed these intensity, you can generate classification of flood, coherence change detection. You can extract various features. You can detect ships. You can refocus on your features within the scene. You can generate velocity maps. You can detect various features such as ship, oil tank, etc. There is one new tool within the SARscape with this latest release, which is called National Imagery Interpretability Rating Scale. So this tool provides you the rating so that you can distinguish between what kind of analysis you can done using using the available SAR data which you have. So this is very much handy tool when we want to work on different kinds of analysis. So the filtering tool which I was talking about, here you can see an example where you see the original image here and having applied frost tool, refinedly and Lee Grande, you can see the difference between these filters, and you can now see how much clearer the SAR image is having applied those speckle filters. Reiterating upon the new and the latest tool which has been in this latest release of SARscape is inverse SAR detection and refocusing. So when you see the SAR sensors capture the images with phase information within those. So when one object is moving on the surface, there is some subtle hazy effect with those features that appears within the phase of that pulse. So to refocus it, there is one tool called SAR inverse detection, which clears the Doppler effect within the phase, and it produces a simple and much crisper image to identify the feature from. So here you can see one defocused image and one refocused image, which is of a bulk carrier. You can see different example after refocusing and before focusing. So this tool is very much handy when we talk activity and we monitor the sea area, trade routes, and different kinds of port activity. Coming with another tool, here we have one AI-driven tool which detects oil tanks available near ports and different facilities. So this tool uses an AI model to identify between the uh, pulses and intensity of the pulses and detect the floating roof oil tank and fixed roof oil tank. So it also distinguishes the height of those tank, and you can calculate the volume of the product available within those cylindrical tanks. So here I will show you the interface. I had one demonstration ready for you. So to introduce you with the interface of ENVI SARscape, ENVI SARscape module comes with ENVI itself. So you get to a similar interface as of ENVI. But talking about the data support, you see a large amount where various filters and very diverse SAR sensor support is available, whether it is openly available SAR dataset or commercially available SAR dataset. Even NISAR support is also there with RSLC level 1 support and GSLC image support. You can see uh, just I talked about different workflows which we get in SARscape. So these workflows are semi-automated kind of interface where you ingest your data and they will produce you the output within single or few clicks. So these workflows have some parameters set by default. So you can change those parameters based on your preference so that you can produce much useful and much relevant analysis as per your requirement. So here you can see different repositories and different CSV fields which can be changed as per your project requirement. There is a specific preference as well for mosaicing, for geocoding, for co-registration. You can change all these preferences as per your requirement, as per your project demands. So this will allow you to work in an automated interface as well, and to get a crisp and sharp result as well. So to move on with the demonstration, here we have oil tank detection tool. This tool is embedded with AI model, and it detects intensity of those pulses to identify between floating roof oil tank and fixed roof oil tank. So this is capilla image, and uh, this is of Jamnagar area in Gujarat. So there is very large oil facility there. So I used this tool to identify between which is fixed roof oil tank and which is floating roof oil tank. So here you can see yellow one is the fixed roof oil tank and red one is the floating roof oil tank. And here you see in attribute table the different height and roof height. So the total height of the tank and the floating height of the roof. So using these variables, you can produce how much liquid or how much volume of this tank was. So this again gives you an advantage over what kind of material was there in that tank. And moving ahead with another tool of SARscape, which is building height estimation. So this tool comes with basic module itself, and here uh, you can identify heights of different feature within the SAR image. So this is a solution-ready tools which ENVI SARscape offers. And on these clicks, you can see the height of that building, which says 171 meter. You can identify different heights as well. I'll just say click on stop and see. So this says it is 96 meter tall. So this is one urban area in Southern American continent where you can see many skyscraper, and I can identify how much tall these skyscrapers are. Moving ahead to another demonstration, which is for flooding classification. So here we have ingested NISAR dataset, NISAR GSLC data, in order to identify the flooded area in the Dhemaji and Shivsagar district of Assam. So in the previous month, uh, Assam was going through a major flood disaster, which is a cause now. It happens every monsoon season in Assam. So we can see how much area has been affected and how much water body flowed, spilled over. So the benefit of using SARscape tool and SAR image here is that we can acquire images even in the most cloudiest season, and we can do processing on a very quick and large scale here. So this is the workflow for flood classification, where you just provide your pre-event image and post-event image, and it will do all the pre-processing such as multi-looking, co-registration, filtering, geocoding, and eudiometric calibration, and then it will identify based on the intensity dip between two images how much area was flooded. So here you can see the flooded result. This is Brahmaputra River, as it is evident, where Assam has Brahmaputra River, and the red pixels are the area which was flooded. So we can see there are two images. One is pre-event image and one is post-event image. So comparing pre-event and post-event image, you see the post-event image has many dark pixels. So these dark pixels are area where water was locked. So water logging happened in these areas. So you see how the red pixels are there. This is flooded area. One beautiful thing about this tool is that it has identified over the persistent water. And here on the islands, which you can see, initially the islands were large, but due to flooding, some portion of those islands submerged. That's why this is saying that this is flooded area. So you can see even on the smaller land piece, it is showing this much accuracy. So how this is what the capability SARscape provides you with. The other capability of basic tool is intensity processing. So intensity processing is very important when we talk about change detection over a period. Uh, and we want to identify how much change have occurred over the surface of Earth. The feature could be anything. For my case, it is one glacial lake. This is Gepan Ghat Lake in Himachal Pradesh, where reports are saying that this lake has extended more than 200 times due to glacial melt, and the perimeter of this lake is continuously increasing. So since this image is in the valley, in this lake is in the valley, very deep valley of two different ranges, I used SARscape because non-cloudy images were not available. So this lake falls in shadow zone of optical sensors as well. So I used SAR images to identify how much change have occurred within the 7 month. So this image is of from April 2025 to November 2025. So every month I captured one image and I did intensity processing using the basic workflow, intensity time series workflow, and we can see how this has changed. So here you can see how this lake has changed. Here in this area, you can see this range as the time proceeds, as the winter comes from April to November, this glacial has melted and has expanded the periphery of the lake. To justify on this, we can use the time series analyzer tool as well, where we can see on the SAR how much intensity dip is there. So it will take the meta information from the images, and it will show that from April to May month there was slightly increase in the pixel intensity, but the intensity dipped very severely from the month of June, and it kept on uh, depleting till October itself. So this shows that there is some kind of depth in this image, in this location, and you can just reconfirm it using different pixel. So on the blue part, you can see it is again dipping, and the dip is minus 22 decibel, which shows that there is the depth is quite a lot, and yes, the lake is expanding. So this kind of information you can extract on month basis, even with accuracy and precision. Similarly, you can do change detection as well, where you can do coherence processing. So I have used image of South Lonak Lake, where an Clough event occurred. So this during this Clough event, the southwestern portion of the Lonak Lake got washed away. So I did intensive coherence processing and identify how much area was affected and how much area was washed away. So talking about coherence means similarity between two images and similarity between two SAR images. So the red pixel shows very much similarity, but blue pixel shows there is last or least similarity between those images. So you can see on the periphery of this South Lonak Lake, large area has been washed away, and you can find that area using the coherence tool of SARscape, and you can measure how much area has been washed away and how much area has been affected and how much this lake got expanded. Moving ahead to another module of SARscape, which is interferometry module. So when we talk about interferometry, we should keep in mind that SAR image is very complex initially, and at one level it comes with two kinds of information, which is amplitude and phase. So amplitude is the strength of the pixel, strength of the pulse, and the phase is the travel time of the pulse. So you can harness any kind of insight from these two pixels from kind of information together and separately as well. So when we talk about intensity interferometric applications, these kinds of application tend to use the phase information and the difference between those phase informations, and they does this phase processing and analyze different kinds of different kinds of activities such as deformation, displacement, and we can use this phase information to generate very precise topographic maps, which is called DEM. So using this phase information, this difference between this travel time of the SAR pulse, you can generate DEM, a digital elevation model of anywhere of on the surface. With DEM generation, there comes one another toolbox and one another concept in SARscape. This concept is baseline estimation, and the tool is called DEM extraction tool. So before moving on to the demonstration, I would like to take 30 seconds to explain on this concept of baseline estimation. So when we work on harnessing this phase information, the change is very much minute. The change is very minimal and very minute. So so we do not get lots of noise from the data and from the atmospheric interference. We tend to use a baseline of those phase information. So there is one tool called baseline estimation, which helps us to generate very precise and accurate map of these applications where we work on them, where we work on generating them digital elevation model. For these, DEM generation, we use INSAR DEM generation workflow or DEM extraction workflow, where we generate interferogram of different images and do adaptive filtering and identify coherence between those phase. So, those phase are further unwrapped, and the vertical height is being converted into vertical height is being converted and then geocoded in order to get one DEM, one digital elevation model. These phase difference and these phase conversion to vertical height and then geocoding those phase information generates us very accurate topographic maps. These maps could be DEM as well as DSMs. So moving on to the interferometric workflow, here we see there are different tools such as automatic refinement and manual GCP refinement. So I just used INSAR DEM workflow, where you can proceed with interferogram generation, coherence and adaptive filtering, and phase unwrapping and converting the phase into height and then getting one DEM. So this area is Ganderbal district of Jammu Kashmir state. And the image which I have used here is RSLC level 1 image of Nisar. So the final product which I get is similar to this, where you can see the height information available on this scale bar, where you see how much these topographic terrains, this mountainous terrain is available, is being visualized, and how the valley is being visualized within the dam when we have used inside dam generation workflow. Since there is NESAR support, so two kinds of product are supported within SARscape. First product is RSLC level 1 images. This is a range Doppler image, and second is geocoded or GSLC images, where you can do intensity processing and interferogram generation and proceed on to generate different kinds of output for different applications. Another application of NSR is on agriculture. So you can use L band and information from L band to penetrate tree canopy, identify the trunks, and uh, do different kinds of feature analysis within agricultural field. Interferometric stack. So moving on to the same concept and to different ancillary module of SARscape is interferometric stacking, where there are two kinds of tool available. First tool is PS, which is persistent scattering, and second tool is small baseline subset. So PS is for interferometric stacking toolbox provide you capability to monitor the minute change between the surfaces, how much deformation have occurred and how the surface is changing. So these two tools enables you to identify changes in different kinds of setting. So PS is for urban setting, urban region, and linear features, whereas small baseline subset tools are for natural and clustered setting, where you can identify deformation and surface change in localized territory, such as mountain slope or mountain valley or some large desert area as well. So these are for open fields, for SBUS is for open field application and large clustered field application, whereas PS is for linear and some urban setting applications. These tool works by connecting multiple interferogram and reduce noises by using atmospheric information, be it from GACOs or be it from MERIS, and then using these information, and they generate phase difference, where they monitor the ground deformation and produce you with the deformation report and deformation product. So since phase information is very much affected by the atmosphere, so there are two tools, and which is atmospheric effect removal tools, where you can ingest MERIS data or GACOS data in order to correct your phase information and generate very accurate information and very accurate deformation information from your images and from the surface. So again, uh, onto the ENVI for the demonstration of one GLOF event. This is again South Lonak Lake, where I have run PS tool in order to identify how much this slope got deformed. So I'll just show you the vector file of this. You can see a large cluster where a huge mass have been washed away, I can see how much mass was washed away using this tool and how much deformation occurred. So here you can see over this slope, over this area, more than minus 20 mm of soil was washed away due to the cloth event, due to this disaster. So you can do on these kinds of analysis and go on and produce one dashboard and integrate your solution to ArcGIS environment and cloud mapping environment, web mapping environment, where you can produce this kind of information to your decision maker who can take decision and whose decision will lead to quick mitigation and response over this over the localized disaster zone. So here you can see these widgets. This graph is changing as per the zoom level and as per the scene which I am changing. This error. So since this is a very large data set, this is taking a while to process this information, but these kinds of dashboards and these kinds of application help us to uh, normalize and identify what kind of activity and what kind of analysis we can produce using SARscape tool. Since there is interoperability between SARscape and ArcGIS, you can use different applications and take onto the WebGIS map, WebGIS or ArcGIS Enterprise, and produce different kinds of applications for decision maker and for the for information sharing within your organization. Further ahead, you can automate your monitoring and scale up your process using cloud environment, and you can monitor those area on continuous basis using different kinds of offering of NV server and NV product suites. One another module which comes with SARscape is SAR and polarimetric module. So this polarimetric data uses 4 poles or 4 quad pole information in order to analyze different kinds of biomass and environmentally sensitive information from the SAR image, where you can work on forestry, agriculture, and coastal zones in order to identify different kinds of features, species, estimate biomass, uh, detect leaks, and different residue from the crop, all those all together using the SAR and polarimetry module of SARscape. So this is one example of polarimetric module application where we have used the image of one forest and identified biomass as per the as per of different zones within the forest, where the biomass was dry, where the biomass was live, like this, which in order to help us identify the regrowth area in the forest. So we are moving towards the end of this webinar, and I would like to conclude by saying that by reiterating that we learned to ingest SAR images, and we got to know about the pre-processing workflow of single pole, co-pole, and multi-pole images in time series manner. We saw the capability of solution-ready tools which are available in SARscape, and using INSAR capability, we monitored deformation and displacement, and we also generated different kinds of topographic maps such as TEM. Well, at the end, I highlighted the capability of algorithms and processing filters and algorithms, where you can use those filters to visualize, to integrate and disseminate different kinds of information, and to scale up your processing at a cloud level. That was all from my side. I hand over the session to Samkit again. Over to you, Samkit.
Thank you, Abhishek. Thank you for this insightful session today. So I believe Abhishek has delivered the most webinars in this week. And he has put in a lot of effort to collate all of this material together, resources together, and plan for you all. We have a few questions in the chat box here. Rest of you guys, if you have more questions, write to us in the chat box right now, right? So that we can take them up and address those. Meanwhile, I'll start uh, asking those questions that are there in the chat box. Although we have answered some, there are a few more questions that need to be answered. So I would request Manjusha and Abhishek to help us with those answers. First question that I would like to read is, if I wanted to process the urban land subsidence, which method is suitable, PS or SBAS?
So, as I already mentioned in the slide itself, like those tools are for different kinds of setting. So, PS tool is for urban environment or urban landscape setting, where you find linear features. So, in urban area, there is abundance of linear features. So, you can use PS tools. So, the tools available in PS toolbox, you can use those tools to identify deformation and subsidence in urban areas.
Thank you, Abhishek. Meanwhile, I request all of you to scan this QR code and share your feedback on this. Share your feedback on the sessions that we had, right? And of course, ask questions if you have while we address to the other questions that are there here in the chat. So the next question is how to process stereo DEM using NISAR data.
I'll take that up. So we have a dedicated stereogrammetry module within ENVI SARscape that will take care of all this. So we have the step-by-step wizard that will help you to get the DEM from the stereo NISAR data.
So I would encourage you to write to us at info@esri.in with this query again, right? So that we can connect with you again and probably have a demonstration or probably discuss this in much more detail in the days to come. Now I'll go to the next set of questions. In what way SAR is used in oceanographic applications?
So I'll take that up again. So in case of oceanographic applications, what we can do is we can have tidal effects that can be understood, and we can understand how the coast have changed over the period of time. And if there is a low-lying area, how we can monitor it continuously and understand how much of that I would say deformation or subsidence is happening towards the coast. So as the low-lying areas are still prevented, or we can it can be saved or something like that.
Thank you, Manjusha.
So, Samkrit, one
yeah,
second.
please.
So, I would like to add on what
Please
Manjusha
do.
said. So, having when we say about oceanographic application, so we need to understand the of what kind of analysis and what kind of study we want to do. So, just like I showed one example of ship detection in the slide itself. So there are different tools available within SARscape to identify ship, to identify oil spill as well as using polarimetric module of SARscape, we can identify different kinds of environmentally sensitive features within shoreline of any ocean. So be it mangrove studies or be it coral studies or different kinds of parameter study of ocean water, we can do it using SARscape polarimetric module.
Thank you, Abhishek. The next question is, in case of wave slope, what is its utility in oceanographic point of view?
So, in case of wave slope, again, like Abhishek was mentioning, we need to understand what is the application per se. Majorly because SAR looks into the DM generation and interferometric processing and deformation. So we need to understand more on what is this wave slope or wave steepness that they are looking into.
So if you share more details with us, sir, at info@esri.in, we'll reach out to you and get and probably address to it in a much better manner, sir. The next question is, can we combine the ascending and descending data as... Okay, the question is unclear. Let me rephrase it in my mind. Ascending and descending data has come. Okay, I'll just read it as it is. Probably you can figure this question out. Does we combine the ascending and descending data as combined for PS in SAR?
Yes, we do. So since it's both for PS and SBus, so we can what we need to do is we need to process the ascending separately and the descending separately, and finally we have a tool that would combine both the meta or I would say the result files and give you a proper ground. I would say scenario wherein the final PS would be vertical as well as the horizontal displacement that would have happened. So then once we merge both of them, the resultant would be the vertical as well as the horizontal movement. We can do that.
Next question is, can SAR penetrate camouflage? To what extent and which polarization would be best suited?
Okay. So in this case, I would say there are different bands. Say C band cannot come through the canopy, but with NISAR dataset, we are very hopeful that definitely with SNL band, they can penetrate through the canopy and we'll be able to detect the camouflage. Though again, we'll have to test it out. But yes, SNL band will help us to do that.
Thank you, Manjusha. Okay, so the next question is, sir, is it possible to give any sample data set for each session for us to do some hands-on the demo showcased? Okay, this is an interesting question. So most of the data that we used here were freely available open source data sets, right? I don't think we have used any paid data sets apart from the ones for photogrammetry, right? Of course, they were drone and high resolution satellite imageries. But other than that, we used all open source data sets from Sentinel, NISAR. What else, Manjusha? I think it was just Sentinel and NISAR, or did we use any other data sets in the course of
So
this?
there are certain sample datasets that are available for on say Capella sites. Capella has given more of the archival than ISI. So all the sample datasets were also taken and we could work on them.
Okay, thank you, Manjusha. Then there is another question. How can INSAR be used to monitor land subsidence and slope instability in mining areas?
So, okay,
Go ahead, Abhishek.
I'll continue. In mining areas, we can generate interferograms, and then we go on to monitor how what level of displacement is there, if there is any, and we can use INSAR displacement tool to identify on a continuous basis how the landscape is changing, provided if there is a mining going on, if there is active mining going on. So we can use displacement map. We can do these kinds of monitoring, and apart from displacement, we can also monitor deformation using PS and SBus tools. If the purpose is to identify surface change, if there is some other purpose, we can work differently.
Okay, thank you, Abhishek. Find out these data. Okay, again, there is a question on the sample data sets. Where can we find out these data of Sentinel and NISAR? So these are available on Sentinel data is available on Sentinel Explorer as well as ESA or USGS, Manjusha?
ASF. ASF also has
Okay, yeah.
Alaska's
Alaska's,
satellite
yeah,
facility has both the NISAR as well as the satellite the Sentinel one. Also, Bhunidhi supports all
yeah.
these things. So Bhunidhi also
Bhunidhi also
has,
has some Indian
yes,
NISAR data sets, right? So you
NISAR
can get
data
those
for
data
S
sets,
and L as well as the Sentinel data. They're all available.
right? I think we are on a time here, although I think there are a few more questions left. But we would request you to write to us at info@esri.in so that we can go through it and address to it in much more detail. Right. So thank you everyone for this insightful questions. If we weren't able to answer, please write to us, as I mentioned, at info@esri.in, and our team will respond to you as soon as possible. So before we wrap up the series, let's summarize today's masterclass from microwave pulses to insights, redeeming pulses into information. So we saw how SAR processing bypasses cloud cover and darkness to deliver uninterrupted Earth observation data. We explored how radar interferometry measures ground motions, structural stability, and subsidence down to the millimeter level. Most importantly, we demonstrated how ENVI SARscape simplifies complex microwave calculations, making radar intelligence accessible and directly usable inside GIS workflows. So today showed that SAR is an essential tool for monitoring an ever-changing world, right? So as we conclude this session, we also mark the end of this 5-day imagery and remote sensing webinar series. So over the course of this week, we covered the entire spectrum of modern imagery GIS, from GeoAI to deep learning on day one, image analyst and image server for ArcGIS Enterprise on day two, ArcGIS Reality on day three, ENVI for advanced spectral processing on day four, and SARscape, ENVI SARscape today for microwave or SAR analysis. So our ultimate goal throughout this webinar has been to show you that the imagery is no longer just a backdrop map, right? So it is an active, dynamic source of location intelligence that can drive faster, smarter decisions for all your organizations.